Hi, I'm Bailey from MyMathExperts, and today I'm going to show you how to solve the following problem. What is the domain of the function f of x equals x plus 5 over x squared plus 2x minus 8? So first of all, let's define domain. Domain is all possible x values. So every x value where when we put it into the function, we are going to get a valid y value. Now, that may seem kind of weird to you because you might think about, okay, what are non-possible x values? Like, what would that look like? So it's easier to think about domain, in my opinion, in thinking about what are the restrictions on the domain? What would be a non-possible x value? So let's talk about restrictions on the domain first. Let me make a little side section over here. So basically, when do we get an impossible x value, or an x value where when we put it in, we don't get a y value out? One of those situations is the square root of a negative number. So for example, like the square root of -4, because that's going to get you into imaginary numbers. So we would just say, for our purposes, if you have something like the square root of x, then x cannot be, x can't be less than 0. Basically meaning x can't be negative. That would be a restriction on your domain. Another thing is you can't divide by 0. So for example, if you had like 9 over 0, or if you had something like 9 over x, then you would say x can't be 0 because we can't divide by 0. So let's look at our problem here. We have x plus 5 over x squared plus 2x minus 8. We don't have any square roots anywhere, but we do have a denominator, and we know that our denominator can't be 0. So let's set our denominator equal to 0. Let's say x squared plus 2x minus 8 equals 0. And if we solve this problem, it's going to give us our restrictions of our domain. So this is a quadratic. So in order to figure this out from here, we're going to need to factor it. So we're going to have to think about, okay, what two numbers multiply to -8, add to 2. That would be, we know we have to multiply to a negative, so we know we're going to have one positive and one negative number in order to do that. And we know that we're adding to a positive number, so our positive here is going to have to be bigger than our negative is. So our choices are like 1 and 8, 2 and 4. I think 2 and 4 could do it if the 4 is bigger. +4 and -2 multiplies to -8, adds to +2. Looks good to me. So that means our factor pairs are going to be x plus 4 and x minus 2 equals 0, meaning that if we set these up as separate equations using the zero product property, that means that x is going to be equal to -4 and x is going to be equal to +2. So again, these are the restrictions on our domain. These are the x values that if we put these in here, we're going to be dividing by 0. We can even test that if we want. I'll make some more room over here so we can test that. We'll do our check over here. So we'll say one of them was -4. So let's just put -4 in our original equation for x. -4 plus 5 over -4 squared plus 2 times -4 minus 8. Let's look at our denominator here and see what happens. On our numerator, we're going to get 1, but that doesn't super matter. On our denominator, we're going to get 16 minus 8 minus 8, which is 16 minus 16, which is 0. So great, that's getting us a dividing by 0, which again, we don't want. And then our other one was +2. So let's check that. 2 plus 5, 2 squared plus 2 times 2 minus 8. 2 squared is 4. Well, I guess we could do our numerator here. And then on our bottom here, that's 4 plus 4 minus 8. 8 minus 8 is 0. So once again, we're dividing by 0. So that proves that our domain restriction is +2 and -4. And so just in terms of our final thing here, this format is basically saying, this is set notation, these little squigglies. And so that what this is basically saying is the domain is the set of all real numbers, which is why x is just in there. The domain is all x for whatever values x may be. And then this colon is saying, except x cannot be 2 or -4, which is exactly what we came up with. So answer D is going to be correct here. So great. Thanks for coming along with me on this one, and I hope that helped.